It's interesting. I like one of these books for public speaking. It's called Confessions of a Public Speaker, and the first thing they tell you is don't admit you're nervous. So I tell you I'm not nervous because I'm doing this on a regular time, of course, like every time for breakfast. Flying to another city, giving talks. Speaking about flights, that's actually something that I have to tell you. I made some experience with security control at airports, more than once already. And this time they actually asked me, okay, we have the screen of your luggage, and can you tell us what's inside? And I was looking at the image. I thought, okay, I can't remember putting 2 sausages in there. And then we just went through the luggage, and what it turned out was to be those stickers. So that's something that I usually forget to mention at the very end. If you want to take one, get one at the very end. They also took samples for explosives on them. So yeah, that was an interesting thing. But yeah, my name is Matthias. At my day job, I work at JetBrains. Some of you may know them for awesome IDEs. And at night, I build Nuke, which is a personal project of mine, an open source project, for 4 years already now. So finally made it to NDC also. And I'll be talking about build automation revolution with Nuke. My handle on Twitter, project handle on Twitter, so go and follow. And now the first question is, who of you has heard about Nuke before? Maybe raise your arms. Oh, okay, surprising. Keep your hands up. Using also? Now keep it up. Happily? Okay, so those 2 hands that were from the second questions are still up. But for those of you who would like what other kinds of users or companies are actually using this, Avalonia, for instance, in the .NET or open source space, couple of others. Hot Chocolate is also, that's a fun part of doing open source. I also meet very cool people like Michael Stipe from Hot Chocolate, and you kind of get in contact with each other talking about open source development. Of course, also, this is also always a funny question when people ask, is Nuke actually built with Nuke? So yeah, sure. We also have 2 sponsors already, which is very cool, and I'm really thankful for Octopus Deploy and Verticommerce to actually also help sustaining open source projects, so they do a good job. But for all of the others of you who haven't heard about build automation systems, I want to give a brief introduction about what this is. And usually when we talk about this, it's about continuous integration, continuous delivery. Now, I like this image from Gradle very much. So at the very start, so around here, what we do is put code into something, let's call it build pipeline. At the very end, what we try to get are some deliverables, something that can be installed, something that can be deployed, a website, whatever. In between, and I think this is where this picture does a great job, there can be very complex tasks involved. Well, to name a couple of more easy ones, it's something like restoring your solution to get the NuGet packages, compiling those, packaging everything together to a NuGet package, let's say, and pushing this to an endpoint, for instance. But one of the natural questions that always comes with that is, what about YAML? Because like we have GitHub Actions, we have Azure pipelines, you can write your YAML in there. TeamCity has a Kotlin script that you can use. So the question would be, what about YAML? My question to you would be, who's using YAML? So maybe raise your hands. Okay, keep it up. Who's using it successfully and is very happy with that? Okay, a couple of hands are going down. I don't want to speak about YAML. I let others speak about YAML, okay? So we have Claire, for instance, saying, welcome to the world of YAML love. Love. Then we also have Imo saying, okay, he has a master's degree, 20 years of experience building software. YAML is the best thing that has happened to him. Scott seemingly also had a good time with YAML. Yeah. It's not difficult finding those. Yeah, Nick is saying, okay, YAML is enough for the next 100 years of technology improvement. People are so excited about YAML, they even put a website up, noyaml.com, from Joffrey, very cool person. Norway is on the line 33, because when you put NO somewhere, it goes boom, your YAML, because it's interpreted as a Boolean value. I jumped the bandwagon. I also created a blog post around that, which is my most favorite and popular blog post. But in the end, those are the issues that we see with YAML. When we write YAML, we commit a lot, see if it works. Usually it doesn't. You commit a couple of more times. Yeah, I even blurred the author, not to shame anyone, but it's every one of us, right? The second thing is this. Yeah, I like this YAML development at its best. Good tools also that help you. But yeah. In contrast, what does a build system give you compared to YAML? Yeah? And by saying build systems, I mean predominantly, and Nuke is one of them, make tools. Yeah? This is the term that we usually refer to those tools with. And there's not just Nuke, there's also, off the top of my head, Cake Fake, Bullseye is very cool, Flubu Core I haven't checked out. I think those are the predominant build systems in .NET. But in contrast, what do they give us? So the first is shorter feedback cycles. Because we put everything in this build system, which is .NET, as you will see in a moment, and this gives us very short feedback cycles. We write something, we can execute it immediately. The second is we're also saving build agent time. Like, just imagine you're paying for those CI agents that execute, and it's just continuously updating YAML. Well, you're occupying other colleagues maybe with that. The third is we're skipping vendor login, because once you might want to change, it's one of those questions like changing the cloud provider. But it may happen that you want to change your CI system, and having everything implemented in YAML with GitHub Actions, for instance, even switching to Azure pipelines still needs some work to do. You can execute that locally. That also implies the shortest feedback cycle. You have better versioning, branch-based, so to say, because the code is just versioned along that. And you have shared ownership. That, for me, is the biggest thing about this, because you first need to become a YAML developer to actually master this. But having everything in C# or .NET, this is approachable to every one of you, I suppose. So with that, let's quickly jump in here, and I will show you how a typical build in Nuke looks like. So this is, this is something that will be generated once you execute Nuke and the setup tool. So usually you can do this either if you have set up your repository already with a .git folder, then you can just call Nuke and it will execute the setup. In this case, I already have something set up, so I can just pass the setup command again, which then will ask me for a couple of parameters, like what should the build project be named, where should it be located, what version do you want to use, and also do you want to add it to an already existing solution. And that's the great thing about this. So I will abort this and just go back, because you already see this build project already belongs to the solution. And I also have a couple of code generated already. The most important part is here in the CS project file, which is this output type exe, which means this is just a console application. Yeah, very low entry barrier, I think you say. Everyone knows what's going on here. You also see I have a couple of NuGet references already. But let's go back to the build. Here you can see something that every console application has, static int main. The only thing it does is delegating to Nuke as a framework to execute your build. Yeah, in this case, compiles the default target. And what you also see, and I think this is very much this is very much in contrast to all the other build systems. Let's take MS Build as an example. In MS Build, targets or build steps, I use those interchangeably, are written as strings, magic strings, stringly typed, yeah, so to say. Whenever we want to rename a target, we have to do search and replace, basically. In Nuke, those things are actual symbols. And it's really great being in front of an audience again, because now I can ask you, what type of C# construct is this? I mean, this one target. Anyone? A property. A bit more information, what does it return, or how do you deconstruct this part? It's a target, yeah, but it's a return type.
It's a delegate.
Yeah, all right.
So discarding the parameter.
Yeah, so it's a delegate. This first part is expression-based, basically, and the second part is the whole delegate. Yeah, target is a delegate. Oh yeah, sure. Sorry. Sure, let me do this. I totally forgot. Okay, let's go by 18. Is that big enough? No? Okay. 20? Still no? I can go higher, that's fine. Everyone? Otherwise scream. Okay, don't scream. Okay, so those are the targets. And you can just rename them. That's the really big thing about this. So even here, restore is used over there. You can see I can rename, restore, it adapts to that. Also, what you can do is put a breakpoint there, right? This is something not all the build systems come with, particularly not YAML. So in once, I can say in writer, for instance, here clean debug. I should have changed my resolution, but anyway, this will work anyway. I can just debug there, debugger halts at this particular point, and I can inspect what's going on with these values here. Yeah. So this works out of the box without any extension or something. Those little icons here, those are actually coming from an extension for writer in this case. But let me go back to my slides. They're also available for VS Code. In this case, you can see you can run debug target from over there. Also, and this is very important, to skip dependencies, because this is something that you really don't want to do. If you're working on a build pipeline and the last part you're currently troubleshooting that, you don't want to go over and execute compile again. But you also don't want to change the build definition that you already have, because then you forget to revert it, and yeah, it's just a mess. So you have these opportunities. This is how it looks from Visual Studio. So very, very similar, actually. Now the question is still, what about YAML? Yeah, because at the end of the day, we can't just give our build to, let's say, GitHub Actions. It doesn't know what to do with this project. Actually, one thing I forgot to mention is down here in the left, we also have something called Bootstrapper files. Those are for PowerShell, CMD, and Bash. And what they do, well, PowerShell is Windows. If we exclude, let's say, PowerShell core, Bash on Unix, CMD actually works cross-platform, very cool technique. But what these do is to take the global JSON file, so I have one around here, and making sure that this particular .NET version is already installed. That's the task that those bootstrapping scripts have to do. And the interesting thing about this is you may know this whenever a new .NET version comes out, people are asking, okay, when is the new .NET version available with a particular image? This is not necessary in this case, because it will automatically, once the .NET SDK is available for download, this will make sure it's installed. Yeah, so you don't have to wait for anything. Just update this global JSON and it's done. But let's go back. What about YAML? Yeah. So how do we deal with that? Because we don't, it can't invoke this build bootstrapping scripts automatically. Now, the idea here is to go to the build and add some attributes. Attributes that kind of mimic what this YAML would do for you. And I will go, in this case, with GitHub Actions. The first thing that you usually do with a GitHub Action workflow is to give it a name. In this case, I would just do, this is so low I can't type. Anyway, continues, it's still written correctly, right? Yeah, like this. Second thing, giving it an image to execute on. In this case, really nice. I think you have code completion for that. You know what kind of images are available. No typos or anything. So let's go with Ubuntu latest in this case. Something more that we have to do, you could add another image if you want to go like metric style, more or less. But we will stop here and say, okay, I want to execute this workflow on a particular event. And the most common events are push, pull request, workflow dispatch. I will go with push in this case. And the last thing we have to do is to define what particular target should be executed on the GitHub action. So that is usually done with invoked targets. I can, again, pass an array for that. And the really cool thing about this, and I'm so happy that the name of operator works here, is we can reference the targets at the very top in this attribute. So for instance, we could say we have a pack target, just put the pack target in there, reference it with the name of operator, and again, once I rename this, it will just propagate. That's a basic IDE feature. Now, one thing, and that is for later, just so that I don't forget it, I also want to enable the GitHub context. I can't tell you just now what this is about. But afterwards, what you have to do, because this is not, it can be just magically create the YAML just by writing this, although theoretically with the source generator, which I know could be, but no, not in this case, you have to execute Nuke at least one time. Because then it will generate those this configuration. You should actually also see it in the output. So here, GitHub Actions continues, and we can browse there. Where is it? Here. Continues, and this is what has been generated, basically. There's a lot of typing that you don't have to do anymore, and it also comes with a couple of nice things, like, for instance, caching. Caching NuGet packages, caching the build project assemblies, so to make the next build run a bit faster, but otherwise just executing the build from here. Okay, so far so good. This stuff, and I will show you later how this looks on the CI, but at this point I will already tell you that this exists for all the major. I will resolve those issues a bit later, but this exists for all the major CI services. So we have AppWare, for instance. We can even pass a couple of secrets here. Azure Pipelines looks quite similar. There are some tiny little things that are a bit too detailed, which I won't go into, but generally I think you get the sense of this. It's always just an attribute that you put on the build class, and it will generate the related files for that. This, for instance, is TeamCity. AppWare here is a bit shorter, etc. Okay. So now I'm not exactly just to summarize up until here. What Nuke brings is a console application, something everyone can approach. It also comes with full IDE support, and that is navigation, refactorings, debugging, everything that you know from a good IDE. Targets are symbols, and that is by design, so you won't run into those magic string typos. You can even separate configuration from implementation. That's something I forgot, actually, because we already have this solution field here, and that will be fully initialized, but the you see it doesn't actually assign something because the value is provided from the attribute, and the actual path to the solution is taken from the parameters JSON file. So you have a clear separation from implementation and configuration. Okay, let's go back. We have the bootstrapping, and we can put the no YAML hashtag on our builds. Now I want to go a bit more into detail and show you a bit around how to implement something. The first thing that I maybe also forgot is what you always can do if you write some targets and you compose what kind of build steps do you want to have. And of course, let me just, okay, we remove this again and then just uncomment it a bit later. But we can create a HTML report of our build, which is sometimes very helpful to know how our targets are connected. Yeah. So this very first edge here, this is an ordering dependency. That means clean is not necessarily a dependency of restore, but only if these two are executed together, clean should be executed first. Yeah. Whereas the solid line here, and I hope you see it, but the solid line here represents a hard dependency. So compile always requires restore to be executed. And there's also a third kind of edge, which is triggers, which we don't yet have. But this is something, let's say you have an announce target and a publish target. Usually what I see people doing is saying announce depends on publish, and then from the outside you say build announce. But this sounds a bit wrong, because what you actually want to do is publishing something, and announce is just a byproduct of that. So yeah, that is something that where you can take a look at your builds pretty quickly. But now let's get back to coding. So one thing you've already seen, which is the solution attribute, which automatically initializes this thing. There's another attribute which is called parameters, and this helps you to get input values from the outside into the build. This is also something that I've seen a lot with other build systems, that they always have the setup code where they grab something from the command line or environment variables, cast it and stuff like this. So this is already integrated on a very high level, even because you can see configuration, for instance, is some kind of a class-like enumeration. Yeah, so you can extend it. You can also add custom enumerations if you like, and this also enables you, for instance, to call configuration from here. And you see I didn't fully type it, but RE release, and this will automatically take this information and also give you good earthquake. And this will give you good support in the terminal as well. Okay, so I want to start by implementing the restore target. And Nuke comes with a bunch of tasks. Yeah? The tasks are more or less, or in most cases, are wrapper classes around CLI tools. And those live usually in the tools namespace. And here you have a bunch of them, just to give you a quick glance at them. So all the common things that .NET developers use, yeah, from .NET CLI to CodeCarve and some parts around Xamarin, stuff like this. What we want to use is the .NET tasks. Yeah, that's a class, and from here we can call .NET, which is a method which basically just calls the .NET CLI. And the first argument that we pass are the arguments to the .NET CLI. So for instance, we could say, and GitHub Copilot is doing a great job here also, .NET restore solution. Yeah? Very simple, very effective, no objections. But now I want to give you another example of calling .NET build on your solution. And I want to make it a bit harder, because let's say on the server build you want to also pass some properties, like there's a property called deterministic, which basically causes your build to be binary compatible with the previous build. So they skip things like a timestamp, I think, just to make them reproducible. But locally you don't want that. Yeah? So let's say invocation varies between those two places. So what I do in this case is using a different approach, which is called the Fluent API. .NET Build is a Fluent invocation builder. And down here, I'm just initializing a Lambda. Yeah, GitHub Copilot is taking too much already. Okay, but for the .NET Build, we might want to set some parameters, like for instance configuration. I can pull up configuration from here. I also may want to set the project file. Again, I can use solution. So that's the same on both local and server build. But now comes the interesting part. Well, first of all, also we can say enable no restore. Enable no restore. There it is, because we restored before already. And now we can make things interesting, because we can check only if it's a server build, then I want to apply some additional modifications. Yeah, like, come on, this was not me typing. Like for instance, enable deterministic and enable continuous integration build, for instance. Now this will be different on server and local build. Yeah. And I think this is a nice way of composing different invocations. I want to add one more example to that, and that is people need sometimes to call .NET publish. And that is, I only have to do this with global tools that I need to publish for different .NET SDKs. Meanwhile, I learned you can also set roll forward to latest major. Then you don't need to do that. But otherwise, what we usually want to do is calling .NET Publish on a single project multiple times with different input values, like changing the framework, for instance. Yeah. And I will start. Oh yeah, let's take this away for a moment. I will start with this publish configurations, and I'll just create a permutation. Yeah. The permutation looks like this. So first I start from project, and I think link, I mean the integrated way, not the link chain methods. It's really great for this. So we can say, okay, for each project, and in this case it's not all projects that I want to call publish on, but just one in this particular case. Everyone who has been to the talk of to the source generator talk yesterday of Stefan will be interested in this, because this is using a source generator. If I enable this property here, it says generate projects for that solution. So now this solution type does not only give you the ability to get a project by string name or something, but you can actually go here, solution, and say .NET eval. So this is one of the projects that lives inside, it's here on the left, that lives inside this solution. Yeah? This is generated with the source generator. Now I can follow and say for each framework inside this project, and get target frameworks, for instance. Now this get target frameworks is absolutely amazing. But the amazing part doesn't come from Nuke, I'll be honest. What's integrated is the MS Build evaluation engine in the back, which basically grabs all the target frameworks out of this CS project file. Yeah? And now we can just do project and create a tuple from that. Okay, I should do select, of course. Select, and now we have our build configurations. Now why is this great? What I've seen a lot before was people are adding target frameworks not just to their CS project files, but also to other places where they actually build. But this is just implementing a single source of truth. The build will automatically get the target frameworks from the CS project file and will always be in sync. Now we can just use these published configurations and say, let's say, again, I can enable no build here because we've built before, and then I could say combine with my published configurations. And this syntax is a bit fancy, but the first part is just the settings object again to manipulate the invocation, and the second is the configuration. and then we can set project, and we just get the project, and set framework and get the framework. That's all we have to do. Maybe in the meantime we could check if this is all working, and then just say compile and execute that. Okay, restore, compile. So the first part is just the normal compile, the second is the .NET publish, and done. Okay, good. The next thing I want to, okay, I think that's the wrong slide. Yeah. Come on. The next thing I want to talk about is this. Very cool book, Continuous Delivery, by Jess Humble. Also here, Martin Fowler, great person, very influential. Jess Humble said, the most common mistakes in a build is to use absolute paths by default. I thought that's a great reason to create this public class absolute path. So this is something that Nuke uses internally. But why is that? This path, why to use absolute paths at all? And you will see if we look at the output here again. So here, this is the invocation. And this uses absolute paths everywhere. Why is that? Because when you're with a terminal in some other place and we would just use relative paths, and you can't copy that command. But having it with absolute paths, you can just copy it everywhere. You don't need to change the working directory or anything. So this is very convenient, actually. What Jazz was meaning, actually, was not to use absolute paths like having your colleague's name in some path. Yeah, this is something that he was talking about. And also this absolute path makes it easy to not having to distinguish between slash and backslash, whatever operating system you're using. So actually, this absolute path type is used with the root directory base property. This property always points to the place where the .git folder, for instance, is, or there's actually also a .nuke folder where the configuration file is located. And with that, we can construct additional paths. Yeah. So let's go here. The natural way would be path.combine. I had a great idea, and I think I saw it somewhere else before, using the division operator, overloading that, and then constructing paths just by that, through that. And this is something that we can do, actually. So let's go back, remove this for a moment, and let's implement the pack target. So in this case, again, I will call it .NET pack, again with this Fluent interface, and I can set project to the solution again. I can set, let's say we want to also pass the version in this case. And version, what I usually do is using git version, and there's also an attribute for that to automatically initialize that one. And I can have like a git version, again git version. So this field will also be initialized using git version, using your commit history, and always producing a new version with every commit, somewhere compatible. And this one I can just use here, and then usually I go with this, NuGet version 2, done. And the next one, and this is why I showed you this absolute path construct. We want to put this into some, let's say, output directory. And you also see, I don't actually know what this parameter is being called. I mean, this output directory, I have no idea. I'm just typing something. I'm inferring. Yeah. If you're looking for things like actively, you can actually go here, spin up the help, and then have a list of parameters that you can pass. But otherwise, code completion will help you in most cases. Well, now I can construct my output directory like this. I can even, that's again the great thing. I can use refactoring tools, move this to the place where I want, and I'm done. So this is also was very easy to just pack the target. Now it gets interesting. I put up this quote from a paper, and it says, my favorite way of thinking about build time is basically you have tea time, lunchtime, or bedtime. Your build should run in like 5-ish minutes, however long it takes to get a cup of coffee, or in 40 minutes to 1 hour and 5, however long it takes to get a lunch, or 8-ish hours, however long it takes to go and come back the next day. So hidden message here, get a cup of coffee, get lunch, and come back tomorrow. But also, what this reflects, and this is particularly about tests, is you have a lot of waiting time. I mean, this example that I'm pulling up now is about tests. You have a lot of waiting time. You commit something, you need to wait again, see if it works on the CI. Maybe you can't really diagnose it locally, speaking about the tests. And naturally, what you can do is splitting up test projects and executing them on different agents, like I did here. This was at first like just with the test projects inside Nuke, and you see I have great distribution. One test project has 240, the other has 1 test. But anyway, this is about separating 2 different test projects from each other. It becomes a bit more clear, I think, with this slide. I hope it's not too small, but I will explain it. You read it from bottom to top. At the very low, those are 17,000 tests that have been executed on 3 agents, taking around 13 minutes. In the next step, it was executed using 10 agents, and it went down to 5 minutes. And then again, in a warm condition, so to say, because the agents were already there, took 3 minutes. So from 30 minutes to 3 minutes. Now I have a question. What do you think, how much code did this take to actually go from 3 to 10? Any suggestions? 1 line? 1 character, is that fine? 1 character addition, actually. So this is it. So very similar, we didn't go through this in particular, but writing a test target, we would again call .NET test, combine it with all the test projects, but in this case, I'm using the partition base property, which basically knows, okay, what is my current task that I have to do? Like, you want to execute tests on multiple agents, then 1 invocation would know, okay, I'm agent 5 of 10 or something. Yeah? And one thing you still have to add is this line of code, like to partition this particular target into multiple partitions. Yeah? And this value you can easily change. Yeah? Afterwards, you just regenerate the CI configuration. It will do all the work to create the matrix on Azure pipelines or in TeamCity to add additional build configurations. And then it will just merge together automatically. And yeah, I think that's it about this. And this is also great because looking at CI services that work in a way where you only pay for build execution time. Like I know TeamCity has introduced that very recently, that you can just pay for build time. What you have to calculate into that equation is warm-up time for tests, of course. But otherwise, you could put in 100 there, just to parallelize on 100 agents, for instance. Okay, last thing, or almost last thing I want to talk about is build sharing. Now, what I often see people doing is writing a build and copying it to another project, just because it works the same way. I think many of us know this feeling, and then afterwards you maybe add some build steps, and you just have to synchronize all the places where it has been copy-pasted. So I want to talk about build sharing with that. And in terms of build sharing, I already have something prepared. which is a build component. Now, before we look at this build component, we will take one strategy that Nuke supports in terms of build sharing from several. The naive approach is just putting something in a NuGet package. Yeah, that is not specific to Nuke. It just works with any kind of code. A second would be submodules in Git. Okay, also not my choice, but works. External files is something that I implemented. That was the first strategy that I implemented. It works a bit like submodules because you just provide an URL and it will just download this file before the build is compiling. Okay. The fourth is global tools. That is particularly interesting if, let's say, you belong to a core team and all your derived projects, they're all built the same way. You don't actually need to provide the code to those projects, but you can just provide a global tool that they execute by typing build, and that's all. Yeah? That's the power of a global tool, which you can build with Nuke. And the fifth is the most interesting one. Those are default interface implementations. Yeah, that's a feature of C# 7 or 8. I don't remember exactly. But let's take a look at it. So we have, yeah, this should go there. We have two components. The first one is exception. Yeah. The first one is IPAC, and this is only to provide an entry point for further extension. So IPAC we actually implemented already inside our build over here. Yeah. So we can actually just add this pack, and now, okay, this should also be made public then. You can actually also turn it into an explicit implementation, but at least for this demo it doesn't work because we're referencing it up here at the top. Also you see typo, immediate feedback from the IDE. But okay, we have this pack target just to have this, you know, this is basic interface declaration. The other one for publish works a bit differently because what we have here is an interface with default implementation for the publish target. And this is using .NET NuGet push. Okay, very simple. We pass the source, the API key, and then do something similar that we've already done, but just with the package files. And the package files I'm going to get from the actual implementation. Yeah? But otherwise, this target is already pre-defined. I can deploy it or distribute it in a NuGet package, and then just mix and match, basically. Yeah? Apply it to my build over here. Where is it? Here. I publish, and it's there. Okay, the only thing I have to do now is implementing this one property. So let's actually do this. Let's go like this. Output directory. Yeah, come on. Output directory, glob files. So we can use file globbing here and say, okay, all the packages matching this pattern. That's it. But let's go back to the iPublish target. This does define a dependency. We still need to define a dependency, right? So in this case, we will use the shorthand, which is just mentioning the interface where the target is defined. And this really only works if there's only one target. So otherwise, if there are multiple targets, you would just go there and say, okay, X pack. Yeah. But since there's only one target, we can use the shorthand. Another thing is this requires for API key. Suppose you're implementing a build pipeline and you run it on Azure Pipelines. It takes 15 minutes to compile, run the tests, etc. And then at the very end, it tells you, oh no, you idiot, you forgot to pass the API key. Yeah, and then you just wasted those 50 minutes. Defining requires API key will make a check at the very beginning of the build invocation and check if this parameter was actually supplied. So to say, to have a fail-fast behavior. Yeah. Okay, and one more, and I will show you this just briefly here. one thing that people often do, particularly when drafting something, you know, it's okay, but one thing that is left over is often something like this. Unencrypted, something like this. Oh, closing the string. Okay, you see, it's an unencrypted API key that I'm passing. Could be the actual API key, you know, something like this. And it does tell you, okay, this shouldn't be there because, again, it's maybe a bit small, but unencrypted secret, it's an error. And you can actually move this to a secret parameter, which I already did, so I would just revert this whole thing. Okay, and this is all. Now, from the command line, I could just go ahead and say nuke publish API key. I'm not sure. No, it's not there because I compiled in the meantime, but if we do just this for a moment, then it should appear again. Okay, nuke publish, yes, API key. Let's provide the API key here. And then we will see what happens. Hopefully the right thing. So restore. What's the ending time? 40, right? Yes, okay, good. So publish, this was published before already. And depending on my connection, it should happen any second. But I can switch to something else already. So first of all, I think this was very, well, although I had to explain a couple of things. Oh no! Okay, let's see. Already exists. Okay, but I guess you trust me. There was another version already. We should have just maybe committed, increased the version that is actually built, and then it would work. Anyway, one last thing I wanna talk about is, and this is very exciting because I'm currently working on it, are build notifications. And I'm currently starting with something that works inside Slack. And let's say I just want to commit something really quickly here. And maybe, because we don't need that, I actually just implemented everything that I already had. Let's reset it here. And everything that's new on my build now is this notifications attribute, which also says, okay, I might want to enable cancellation. We'll see in a minute what this is. And I also provided some secrets on the CI service providers, so TeamCity, Azure Pipelines, GitHub Actions, etc. And now I will do a very, let's say, trivial change just to trigger the pipeline again. So let's say trigger. Now we can actually see, so we haven't written a single line of YAML code, of Kotlin code, although I still find this quite nice to use. Or what else is there? For Jenkins, there's also kind of Groovy-like configuration files, but we haven't written a single line of that. It was all generated. And now if I go here, you can see this is already building correctly. So currently running the build. And this already on currently 5 different CI services. What's even cooler, and that's why I mentioned that with those notifications, is this is using Azure functions in the backend to notify inside Slack. I hope at some point also Teams, you know, or OS specific notifications can be integrated. And you can navigate right from here, because this is really something that I hate the most. Well, once you commit a lot and you check something, you always have to go back to the web UI, find the correct place to navigate to the build, see the log, etc. So this is all integrated. And you can even cancel a build from here. Okay, this was succeeded just in time. Let's try it with this one. Yes, sometimes it doesn't work. You know, it's open source. Let's fix it. But usually it does work. But yeah, for all those, you can navigate there. You can even extend those buttons. You could say, for instance, if you have an improve step inside that, like going. I actually use that. I have a third-party signing service that I use for signing the NuGet packages, and I can just pop up a button inside Slack which says approve, and it will redirect me to that very specific URL where I can actually just another time hit approve, and I'm done. And that I can just control right from the build, from inside the build. I think this is not something that you usually can do with YAML, at least I would assume. And if anyone have done this, or any one of you has done this, then let me know. I would like to see how big that YAML file is. Okay, just to close maybe. Those were a couple of, well, very basic use cases, let's say. But it's only the tip of the iceberg. So I use this for so many things already. Like a couple of what we didn't have is like executing benchmarks, comparing benchmarks to the previous run, making announcements, posting to Twitter, Slack, and sending emails, executing and how do you call this? Is it called just gatekeeping in regards to code quality? Yeah, generating documentation, creating infrastructure. I'm also using this together with Farmer, which I think is really cool, an F# library to create ARM templates. I have a custom Git flow even, and I do this for local and remote management, like also updating a file which mentions all the contributors to the project, for instance, just for local management, basically. The bottom line message is, even if you use YAML or anything else, any other build automation system, try to automate everything, all the things. I'm not sure if I made this so clear, but this whole build automation is about eliminating the chance of human error. Once you have manual, let's say, interaction in a build, it will go wrong. Murphy's Law, more or less. And with that, I would say thanks a lot for your attention. If you have any questions, I'm all ears. But yeah, thanks for listening, and I hope you learned something. Yes.
I have in an Azure pipeline a custom task from the marketplace.
Yes.
I extend to use some
Okay.
.NET.
Yeah. So I will just try to rephrase. So you're using Azure pipelines already with YAML, and you're using a task which comes from the marketplace with that already. So, and if you can integrate Nuke, let's say, and run it before or afterwards. Yes, you can. Well, there are a couple of ways how to achieve that. Either you can extend the generation just by adding your manual tasks, so to say. The other alternative is just to switch off this auto generation and then maintaining that manually, because you can also trigger that generation manually. So let's go to Azure Pipelines, for instance. You have this little header here which says to trigger a manual generation, invoke this one. And then you can basically revert those parts that went missing. But I have to say, I'm not a fan for one single reason, because then this kind of collides with this philosophy of having the build execute everywhere. Of course, it depends, like everywhere. It depends. This great O'Reilly book with the elephant. But the best would always be to keep everything in a single place inside the build. But I get this question a lot, actually. Okay, any other questions? Yes?
Is the philosophy that developers can actually create the build code?
Can you repeat?
Do you think it's a way forward to let the developers also create the build
Let who write the build?
The developers using
Developers.
Nuke. Yeah.
You mean this Nuke code?
Yeah, to use
I think
Nuke and attach it to the solution which
Yeah,
they're
yeah.
working on.
This is something, I know some people that are using that in their company, they have seen the switch actually. Because once they introduced Nuke, there was a higher amount of developers that felt able to customize the build, to change something, because they could execute it locally, yeah, because they didn't have to know everything about YAML, how to, import secrets and all that stuff. I mean, I didn't show it. I was reverting that at that time already. But let's go back here. I always forget how secrets are imported on Azure pipelines, GitHub Actions, and whatnot. But with Nuke, all you do is this here: import secrets in the attribute, saying which secrets do you want to import. Yeah. Also keeping the level of strings inside that whole build very low. You can see that. So these are all symbols, yeah, not duplicated in any way or something. So yeah, I would say that. That's a good way forward to make the build a responsibility of the whole team. And that's also why I don't see any issues at all. I even think it's very great to have this in the solution with all the other projects. Yeah.
Yeah. Okay.
Okay, one more question? 3 minutes I still have. No questions? Okay, then what I can say, I'm running, from now on I will put on my hat and you will see me in the crowd, and you can ask questions if you have something later. Yes, one more thing I have. Like I said, I have those Nuke stickers, but I also have, since I'm still have a day job, I also have some JetBrains stickers, if you like those, so you can come by. But with that, thanks again for listening and watching, etc. And I wish you all a good rest of the conference.